We now discuss the solution of a problem from the section Permutations and Combinations. And this question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the second shift. The problem is related to the counting. The given question is the number of ways to distribute 30 identical candies among 4 children C1, C2, C3 and C4 so that C2 receives at least 4 and at most 7 candies, C3 receives at least 2 and at most 6 candies is equal to. We are given 4 options and these are the 4 options A, B, C, D. And the question is that we have 30 identical candies and these 30 identical candies are distributed among 4 children C1, C2, C3 and C4 with the constraints that C2 receives at least 4 and at most 7 candies and C3 receives at least 2 and at most 6 candies and no constraint on C1 and C4. Now required to find the number of ways to distribute 30 candidates among 4 children under these given constraints. We now discuss the solution of the problem in detail. We have 30 identical candies. We are given that these 30 identical candies are to be distributed among 4 children C1, C2, C3 and C4. The constraints are also given. Let Ni be the number of candies. Let Ni be the number of candies received by the child Ci. I is equal to 1, 2, 3, 4. That means N1 is the number of candies received by the child C1. N2 is the number of candies received by the child C2, etc. Now, given that C2 receives at least 4 and at most 7 candies means 4 less than or equal to N2 less than or equal to 7. And further, C3 receives at least 2 and at most 6 candies implies 2 less than or equal to N3 less than or equal to 6. So no constraints on N1 and N4. Now, the given problem reduces to find the number of solutions of the equation N1 plus N2 plus N3 plus N4 is equal to 30, where Ni, I is equal to 1, 2, 4 are non-negative. That means Ni are non-negative integers with 0 less than or equal to N1 and N4 less than or equal to 30 and constraint for N2 4 less than or equal to N2 less than or equal to 7 and 2 less than or equal to N3 less than or equal to 6. So the given problem now reduces to find the number of solutions of this equation with these constraints. Right. We continue in the next slide. So the problem is now reduced to this problem. Now, finding the number of solutions with these conditions for this equation can be done by the method using the generating functions. The number of solutions with these constraints is the coefficient of x to the power of 30. Why x to the power of 30? Because 30 candidate. So the in this equation 30 is here, 30, the coefficient of x to the power of 30. In the expansion of, what are these? The first one is the generating function for 0 less than or equal to n1 less than or equal to 30. So x power 0 plus x power 1 plus x square plus etc. x power 30. So for n2 starting from 4, x power 4 plus x power 5 plus x power 6 plus x power 7 less than or equal to 7. 2 less than or equal to n3 less than or equal to 6. The corresponding generating function we write down is x square plus x cube plus so on and so forth plus x power 6. For n4 as of n1, that is x power multiplied by x power 0 plus x power 1 plus so on and so forth x power 30. So these are the number of solutions with the given constraint is the coefficient of x to the power of 30 in the expansion of this one. Now we write down, that means this implies that is equal to 1 plus x square plus x power 30. And from this second factor, we have taken x power 4 common, written as 1 x power 4 into 1 plus x square plus x cube. In the third factor, we have taken x square common, multiplied by 1 plus x square plus x cube plus x to the power of 4. And for this, 1 plus x plus so on and so forth up to x power 30, that we have written as in the first factor itself as a square term. Now x power 4 multiplied by x square is x power 6. And for this 1 plus x plus 30, we write down 1 minus x power 31 by 1 minus x. We have studied in our earlier classes a power n minus b power n by a minus b formula. That formula we use. Right. That is equal to x power 6 into 1 minus x power 31 by 1 minus x whole square. And this x power 4 multiplied by x square is x power 6 we have written. For this, we have written this one. And for 1 plus x square plus x cube, as in this case, 1 minus x to the power of 4 by 1 minus x. And for this factor, the last factor, 1 minus x to the power of 5 by 1 minus x. Agreed. So, now we write down this as x power 6, 1 minus x power 31 whole square, right? Numerators we are writing, into 1 minus x to the power of 4 multiplied by 1 minus x to the power of 5. In the denominator, we have 1 minus x whole square into 1 minus x into 1 minus x. That is 1 minus x to the power of 4 in the denominator. When brought to the numerator, it will be 1 minus x to the power of minus 4. Agreed. So now we write down x to the power of 6 into square this one. 1 minus x to the power of 31 whole square we have written. And that is 1 minus 2x to the power of 31 plus x to the power of 62 multiply 1 minus x to the power of 4 into 1 minus x to the power of 5. That will be 1 minus x to the power of 4 minus x to the power of 5 plus x to the power of 9. And we have to, for this 1 minus x to the power of minus 4. Do you know the expansion of that one? Do you know the expansion of that one? It is normally taught in a plus 2 level also. Up to minus 3 people normally talk about. For minus 4 there is a formula. So that is the let n belongs to n. Let n be a natural number. Then 1 minus x to the power of minus n is equal to sigma k is equal to 0 to infinity n plus k minus 1 ck. This is a NCR formula we have written as NR. N plus k minus 1 choose k multiplied by x to the power of k, and this binomial coefficient is same as this one, n plus k minus 1 choose n minus 1. Why? It is same as NCR is equal to NCn minus r formula we have applied. Now to apply this one in our case, n is 4 minus n, 1 minus x to the power of minus n, 1 minus x to the power of minus 4. So n is 4. So wherever there is n, you write 4 and write this expansion. Sigma k is equal to 0 to infinity, 4 plus k minus 1, choose 4 minus 1. Agreed. So that's what we have. Now here we can forget about x to the power of 31 and x to the power of 62 in this factor, in the first factor. Why? We are looking for the coefficient of x to the power of 30. Then this x to the power of 31 and x to the power of 62 doesn't give any fruitful coefficient for us, because we are looking for the coefficient of x to the power of 30 only. So these are unnecessary for us. Therefore, in the first factor, we will write only 1. So we write this as, now we forget about that one, and x to the power of 6 is already there. We are looking for the coefficient of x to the power of 30. Therefore, we look for the coefficient of x to the power of 24 and leaving the x to the power of 6. So forget about x to the power of 6 and look for the coefficient of x to the power of 24 in the expansion of 1 minus x to the power of 4 minus x to the power of 5 plus x to the power of 9 multiplied by sigma k is equal to 0 to infinity 3 plus k, choose 3 plus k, c3 x power k. So what is that we want? We want the coefficient of x to the power of 24. So 1 multiplied by this one, if you put k is equal to 24, you will get the coefficient as 3 plus 24, 3. That means 3 plus k, choose 3 when k is 24, minus, here x to the power of 4 is there, x to the power of k is there, we want x to the power of 24, so take the coefficient of x to the power of 20. So that means 3 plus k, choose 3 when k is 20, minus x to the power of 5. So the coefficient of x to the power of 24 will be for this minus 3 plus k, choose 3 when k is 19. 19 plus 5, 24. Plus this one, 9 is here, and looking for x to the power of 24. So take k is equal to 15. Then that will be plus the coefficient of x to the power of 24 in the product will be 3 plus 15 c3. That means 3 plus k, 3 when k is equal to 15. So that's what we have written. This one when k is equal to 24, when k is equal to 20, minus when k is 19, plus when k is 50. So look at that one. So that is when k is equal to 24 plus 3, 27 c3. This is 23 minus 23 c3 minus 22 c3 plus 18 c3. Now the problem is over. Now it's only the matter of computation. So write down for this one. So 27 c3 is 27 into 26 into 25 by 3 factorial minus 23 into 22 into 21 by 3 factorial minus 22 into 21 into 20 by 3 factorial plus 18 c3 is 18 into 17 into 16 by 3 factorial. That is equal to multiply, simplify and multiply. So simplify. The first one is 2925. The second one is minus 1771 minus the third one is 1540 plus the fourth one is 816, and when simplified you will get 430. So that is the answer for this question. That means the number of ways of distributing 30 candies among 4 children with these with the given constraints is 430. Let's look at our options. Our answer 430 appears against option D, and the answer to this question is option D. So that is the detailed discussion of the solution of the problem from the section Permutations and Combinations, and the problem is related to counting. And my opinion about this question is that definitely it is a difficult question, because especially this expansion normally at a +2 level, not many teachers teach, and I doubt very much whether this is really there in the syllabus or not. But anyway, questions are coming, means these are included in the syllabus, and this method is also included in this method. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.